Welcome to the deep dive. Today we're embarking on a journey into something really cutting edge. It's the world of scientific research, but where AI is starting to, well, take the lead.
Yeah, it's moving beyond just assisting scientists.
Exactly. Imagine AI designing its own experiments, uncovering new knowledge entirely on its own.
It sounds like science fiction, but it's happening. It's evolving really fast.
And today we're going to explore a key piece of this puzzle. It's a framework called NOVELSEEK.
Right.
Our mission, basically, is to understand how this could genuinely revolutionize the whole scientific process, moving beyond, the traditional human-led way towards these AI-powered approaches like those smart labs people talk about, aiming for total automation.
That's right. And we've got this detailed paper here that introduces NOVELSEEK. You can think of it almost like a unified self-driving system, but for science.
Self-driving science. I like that.
Yeah. It uses multiple AI agents, all working together across lots of different fields. So for you, listening in, wanting to get the hang of this quickly, thoroughly, without, getting bogged down in jargon.
Which is always the goal.
Exactly.
Mm-hmm.
This deep dive should really shed some light on a pretty significant step forward in AI for science.
Okay, let's dig into it then. The paper points out 3 key strengths right off the bat for NOVELSEEK. First up, scalability. Apparently, they've tested this across, get this, 12 different scientific research tasks.
12. Wow.
Yeah, so it's not just a one-trick pony. It seems it's genuinely good at generating, fresh ideas that improve on what we already have.
So it's not just working on different things, it's actually innovating across them. Suggests a deeper level of problem solving, maybe?
That's what I was thinking. Does it suggest it could unlock things we haven't even thought of yet?
Precisely. The fact it can handle such variety, it points towards maybe a more general kind of intelligence within NOVELSEEK. It's not narrowly focused.
Right. Which hints at potentially a much bigger impact.
Definitely.
Okay, second advantage. Interactivity. It's not some, impenetrable black box. It's actually designed so human experts can jump in, give feedback.
Which is crucial.
And its own internal AI agents can communicate and collaborate too. So even though it's aiming for autonomy, it can still leverage, human domain knowledge.
And that human AI collaboration piece is so important. I mean, the end goal might be full autonomy, but integrating human insight that can guide it, stop it from going down dead ends.
Makes sense. Avoid wasting time.
Yeah, it's about using the best of both worlds, human intuition, AI's processing power.
Okay, and number 3, efficiency. This is where it gets really impressive.
The speed factor.
Totally. The paper shows some pretty remarkable performance gains, achieved way faster than humans normally could.
Yeah.
They give specific examples, like predicting chemical reaction yields. Improvement from about 27.6% to 35.4%. Okay, fair enough. But get this, in just 12 hours?
12 hours, that's tiny. Right. Then, predicting enhancer activity, how molecules boost biological stuff. Accuracy jumped from 0.52 to 0.79 in 4 hours.
4 hours.
And even image analysis like 2D semantic segmentation, identifying objects. Precision up from 78.8% to 81.0% in just 30 hours.
These time frames are just orders of magnitude faster.
Imagine drug discovery iterating at that speed.
Exactly. It highlights the potential to just drastically accelerate research, doing that manually. Months, maybe years.
Easily.
It's that AI capability processing vast data, rapidly testing ideas.
So NOVELSEEK sounds like it could let us tackle these really tough problems with, unprecedented speed and precision, which is the kind of impactful knowledge you're looking for. Okay, let's zoom out a bit. What's the bigger picture here? This whole idea of autonomous scientific discovery.
Right, taking that broader view. Autonomous scientific discovery, or ASD, is basically bringing together large language models, the AI that's great with text.
Like GPT and others.
Exactly. Bringing those together with robotics, potentially. The aim is systems that can literally conduct research by themselves.
Start to finish.
That's the vision.
Yeah.
And the authors cite a lot of foundational work here. Yang, Chen, Wang, others. It shows there's real momentum behind this.
So it's taking those language skills we see in LLMs and applying them to the whole scientific method.
Pretty much. Automating data analysis, coming up with hypotheses, designing the experiment.
Even interpreting results.
Yes. The really game-changing part is their ability to sift through absolutely massive amounts of information. Way more than any human team could.
And find connections we might miss.
Exactly. Spotting non-obvious insights. That's where you might get those aha moments, but maybe, much more often.
Okay, so how does NOVELSEEK do it? Let's get into the nuts and bolts. The paper talks about an idea innovation agent.
Right. That's kind of the starting point, where the initial creative spark happens.
So it's the brainstormer.
Sort of, yeah. Uses a general LLM, but they tweak a setting the temperature.
Temperature, like heat.
Not quite. Think of it like controlling how adventurous the AI is. Low temperature, it sticks to safe, common answers, like reciting from a textbook.
Okay.
Higher temperature. It encourages more diverse, maybe more creative outputs, more out there ideas for hypotheses or strategies. Gives it more freedom.
So you turn up the temperature to get more, like, unexpected possibilities.
Exactly that. The paper even has a sort of formula for it. G takes the task definition.
Yeah.
T, what's the problem? An analysis of baseline methods, B, how people do it now, and the literature,
Yeah.
what's known, and outputs initial ideas.
Got it. Uses the LLM's understanding to explore broadly.
Right.
But, just throwing out random ideas isn't science. How does it refine them, make them actually useful?
Good point. That's the next step. Idea evolution. Similar process, but different inputs.
Okay.
Takes the initial ideas, adds a critique, see how novel is it, feasible, scientifically sound, plus the literature again,
Oh.
and produces evolved ideas.
So it gets feedback.
Crucially, yes, it incorporates critique and learns from related science to improve the concepts. It reflects.
So it's learning, building on itself. The paper gave some specific examples for that reaction yield prediction thing. Can you walk us through one or two, make it more concrete?
Sure. So one initial idea might be something like using a modality alignment objective with contrastive learning loss. Bit technical, I know.
Just give me the gist.
Basically, trying to combine two ways of looking at a molecule. One is Smiles embeddings, like a text code for the molecule.
A line of text representing the structure.
Yeah. And the other is molecular graph embeddings representing it as a network of atoms. The idea was to combine these to predict reaction outcomes better.
Okay, text and network views. Got it. Any others?
Another early thought involved cyclic attention mechanisms, trying to help the AI better understand the ring structures in molecules, which affects their shape and properties.
Right, those ring shapes are important in chemistry. So how did these evolve? How did they get better?
Okay, so the first one, combining text and graphs. It evolved into using something more specific. Graph-derived reaction descriptors.
Descriptors, like specific features.
Exactly. Features like bond types, atom importance. The evolved idea used these to create graph-aware positional embeddings for the Smiles text. So, injecting chemical knowledge directly into how the AI reads the text version, focusing its attention better.
Okay, that sounds much more targeted. What about the cyclic attention idea?
That also got more sophisticated. One refinement suggested integrating those reaction characteristics directly into transformer attention using cross-attention mechanisms.
Oh, okay. Slow down. Transformer layers, cross-attention.
Yeah. Think of it as letting the AI specifically compare the text to graphs, looking for how different parts relate, focusing on the important chemical traits.
So comparing the different molecules we use more intelligently.
Basically, yes. An even more advanced version includes a dual encoder framework, combining a long model with a powerful LLM for the Smiles text with a graph convolutional network for the graph.
Two separate brains, kind of.
Sort of, yeah. Two specialized encoders, and combining their outputs cleverly using attention. These evolved ideas are clearly more complex, more focused than the initial brainstorm.
It's really fascinating how it builds on itself. It's more refined. But how does NOVELSEEK make sure these ideas, even the evolved ones, are actually meet quality level? Right?
Absolutely. That's the job of the assessment agent.
Another agent.
Yep. This one also uses LLMs, but its role is scoring the ideas. Multi-dimensional scoring.
On what basis?
Things like novelty, is it genuinely new? Feasibility, can we actually do this? It also pushes for diversity, so the system doesn't just fixate on one type of solution.
So it weeds out the less promising ones.
Essentially, yes. It selects the most viable, most innovative concepts to move forward.
So it's not just quantity, it's picking the winners. And we mentioned human interaction earlier. How does that fit with this quality check?
Especially for these complex systems, getting input from human experts helps the agents navigate real-world messiness, align with what scientists actually need, ensure practical value.
Provides that grounding in existing knowledge.
Exactly. That link is still crucial.
You can't just let the AI run totally wild.
Yeah, not yet.
Okay, so we have it's not just a random collection of AIs. There's a central coordinator. How does it manage the workflow?
It designs and oversees the research, step by step. Make sure Agent A knows what to do before Agent B takes it. It also manages those human feedback points we talked about, especially for the top-scoring ideas.
Making sure the humans weigh in at the right time.
Right, and ensuring info flows correctly. Like the findings from the survey agent creating literature that gets fed to the idea innovation agent to spark new thoughts.
So it ensures the right info gets to the right agent at the right time. It's like the orchestration agent makes the plan and the others execute the steps.
You got it, that's a good way to think about it.
Okay, so ideas are generated, checked, managed. But how do we go from an idea to something real, like code you can run or an experiment design?
Right, that's where the evolutionary experimental planning and execution comes in. Specifically, this thing called the exception-guided debugging framework.
Exception-guided debugging. Sounds technical.
It is, a bit. The challenge is turning abstract ideas into working code. This framework does it by trying to run the code, catching any errors, exceptions. Yeah, bugs. It catches them, analyzes the error message, uses the LLM's reasoning to figure out what's wrong, and then tries to fix it.
An iterative fixing process.
Exactly. Continuous refinement, trial and error, but guided by the LLM.
So can you break down that debugging cycle?
Sure. Step 1, try to run the code. Step 2, if it crashes, capture the error. Step 3, LLM analyzes the error, looks at the code structure, tries to understand the context. Step 4, LLM formulates a strategy to fix it. Step 5, implement the fix.
And then repeat.
Repeat until it runs clean, or maybe after a set number of attempts.
That sounds like a smart way to handle the bugs you always get when coding complex stuff. Now, the paper said NOVELSEEK was tested on 12 different tasks. That's a seriously wide range.
It really is. Figure 1 in the paper shows the diversity. We mentioned reaction yields and enhancer activity already, and those improvements were big.
Remind me of the numbers again?
For reaction yield, it went from 24.2% baseline to 34.8% with NOVELSEEK in 12 hours, something that could take humans months. Enhancer activity prediction, from 0.52 to 0.79 in just 4 hours.
Incredible time savings. Any other big examples from those 12?
Yeah, definitely. That 2D semantic segmentation, image understanding, up from 78.8% to 81.0% precision in 30 hours.
Still pretty quick for that kind of improvement.
And the paper notes it can handle complex stuff, like debugging across multiple code files working together, not just single scripts.
So project-level complexity.
Exactly. The overall takeaway is that this framework seems genuinely capable of autonomously generating ideas and designing the algorithms to test them, reducing that human effort significantly.
Which is the whole point.
Right. And importantly, for reproducibility, they've open-sourced the baselines and the generated code on GitHub.
Oh, that's great. So others can check it and build on it?
Yep.
Transparency.
Now, all this AI power,
Yeah.
it must cost something, right? Computationally, financially?
Good question. Table 5 in the paper gets into that. They measured compute time in A100 GPU hours. That's a powerful type of chip.
Standard for AI training. Right. And they also track dollar costs using models like GPT-4o and Claude Sonnet 3.7 for idea generation and debugging.
And was it expensive?
Surprisingly, idea generation was pretty cheap, about the order of 60 cents per idea using GPT-4o on average.
60 cents an idea. That's really low. What about fixing the code, the debugging?
That varied more depending on complexity. Simpler, single-file code, like for that 2D CLs task. Less than $1 per run.
Wow.
More complex multi-file stuff, like AutoPCDet, around $1.20 per run. So their conclusion is that NOVELSEEK is actually quite cost-efficient for automated research.
Faster and relatively cheap, at least for these examples.
Right.
Okay, let's circle back to one of the agents, the survey agent. You mentioned it does insightful analyses. What's its role?
The survey agent is really important for keeping the AI grounded in actual science. It basically does the literature review.
Like a research assistant.
Exactly. It has 2 modes, literature review and deep research. In review mode, it searches for papers relevant to the overall problem, selects the key ones.
Finds the background reading.
Right. The paper mentions it finding studies on multimodal transformer-based models for reaction prediction or ReacLLama. Genuinely important papers in that area.
Yeah.
This is crucial for idea generation, especially if it's a newer field the LLM wasn't heavily trained on. It's the AI doing its homework.
Makes sense. What about the deep research mode?
That's more focused. If the AI generates an idea, involving a specific technique, say LLMs for organic synthesis.
Uh-huh.
The survey agent then specifically searches for literature on that topic. It allows for iterative refinement, digging deeper into promising technical avenues.
Kind of like how a human researcher works. Broad review first, then focused searches.
Exactly the analogy the authors use. It mimics that process.
An AI research partner that can brainstorm and do the background reading? Impressive. Now, stepping back again, this idea of multiple AIs collaborating. It feels like a bigger trend, right? Not just NOVELSEEK.
Oh, absolutely. We can connect this to some broader concepts. Remember those AI agent design patterns from Valinor?
Vaguely. Remind me.
They talked about multi-agent collaboration or a society of agents. The trend is away from one giant AI towards multiple specialized agents working together.
Each doing one thing well.
Exactly. And coordinating. That's precisely NOVELSEEK's structure, idea agent, assessment agent, orchestration agent. They're specialists collaborating, not one super AI.
Okay, that fits perfectly. What about the plan and execute loops from Willow Tree apps?
Well, NOVELSEEK is more complex than a simple loop, but it definitely incorporates elements. That pattern is AI makes a plan, then executes the steps.
Which sounds like the orchestration agent setting the strategy.
And the other agents carrying out their parts, yeah. Willow Tree also stressed adapting the plan as new info comes in, which NOVELSEEK does with its iterative idea, refinement, and debugging. So the orchestration agent makes the plan, and the others execute.
Right, adapting is key. And the OODA loop observe, orient, decide, act. That feels relevant too.
Highly relevant. It's a decision-making cycle for dynamic situations, which science definitely is. NOVELSEEK is constantly observing, surveying literature, orienting, analyzing info, deciding, choosing research paths, and acting, running code, generating ideas. It fits that loop.
Reacting quickly, adapting.
Which is essential for efficient discovery.
It's cool seeing these core AI concepts actually implemented like this. What about the robotics angle? A component framework for autonomous mobile robots.
That source emphasized modularity, building complex systems from reusable components, like Orsia.
And NOVELSEEK's agents are like modules.
Exactly. Each agent is a self-contained module. The challenges in robotics communication between components, reusability, are the same challenges NOVELSEEK tackles in its design.
Okay. And Silas Reinigel's agentic systems core value loop, and that agent laboratory discussion on Reddit.
Reinigel's loop is about continuous learning and improvement, clearly visible in NOVELSEEK's iterations. The Reddit thread just shows the buzz, the community interest in exactly these kinds of autonomous research frameworks using LLMs. Shows NOVELSEEK is timely.
Right. It's tapping into something people are actively exploring. We also had that autonomous simulation agent paper.
Yeah, that's very closely related.
Yeah.
Using LLM agents to automate simulation-based research start to finish. It reinforces that this idea of end-to-end autonomous research is gaining traction in different scientific modes, not just, say, chemistry.
Computational approaches, too. And lastly, the planning pattern from Analytics Vidya.
That described using LLMs to break down big tasks into smaller steps.
Yeah.
Which is exactly what the orchestration agent does, creates that strategic roadmap for the research, managing complexity.
Like outlining an essay before writing it.
Good analogy, yeah.
So pulling all this together, NOVELSEEK really feels like a major step towards making autonomous scientific research actually happen.
I think so, yes. It has the potential to seriously accelerate discovery across so many fields.
And it's not just theory. The paper shows it scales, it can work with humans, and it delivers those huge efficiency gains on real scientific problems.
Frameworks like this really do suggest a paradigm shift. Automating the grunt work could free up researchers for the high-level thinking, the creative strategy.
The really human parts of science.
Perhaps, yeah.
So here's something to ponder. How will these increasingly capable autonomous research agents reshape science in the coming years? And what happens to the role of human expertise in that new ecosystem? Definitely something to think about, the implications, practical and maybe even ethical, of these powerful AI tools joining the quest for knowledge.
Indeed. It forces us to think about the future of science itself and that human-AI partnership.
Well, thank you for taking this deep dive with us into the really fascinating world of NOVELSEEK and autonomous research.
My pleasure.
And remember, as we mentioned, the detailed findings, the code, it's all open source if you want to explore further.
Definitely worth checking out if you're interested.
We'd love to hear your thoughts, too, the potential, the challenges. What do you think about AI driving scientific discovery? Let us know.
Yeah, share your perspectives on this exciting and maybe slightly unnerving future.